So what I want to do next is I want to think about the following shifted conics. And so kind of what I want to do is I want to think about, I'm going to kind of give it to us in a nice way the first time, and then we'll talk about how to derive that formula soon. So let's start with shifted ellipses. Shifted circles, we've already basically done everything we need to do there. So let's talk about ellipses. So let's talk about if we were to have x minus x naught over a squared plus y minus y naught over b squared equals 1. We know that this is an ellipse. It's going to depend on whether a or b is bigger, but we know that this is an ellipse where the x values go between a and minus a, and the y values go between b and minus b, except they're shifted. And so really the way that shifted conics are going to work is that you kind of unshift them, you get all the information that you want out of them, and then you reshift them. Okay, so you kind of shift back to the origin, get all the information, and then kind of shift back. So for example, I think this will just be easiest if I look at an example. So let's look at x plus 3 over 2 squared plus y minus 7 over 5 squared equals 1. And so what I want to do is just kind of as our reference, I want to think about the unshifted conic, x over 2 squared plus y over 5 squared equals 1. Okay, or x squared over 4 plus y squared over 25. And so we know here that our x values are going to go between 2 and -2. Our y values are going to go between 5 and -5. Okay, and then we're going to have our parabola that's going to look something like that. We know that our vertices, in other words, the outermost points, that's what we mean when we say vertices for an ellipse, the kind of points farthest from the origin for this unshifted conic are going to be 0 plus or minus 5. Our focal points, which are on the same axis as the vertices, are going to be the points 0 plus or minus c, where c squared is 5 squared minus 2 squared. So that's 21. So this is plus or minus the square root of 21. So that means that our focal points will be something like 4.5. I don't know. Square root of 21 is about 4.5. And I just know that because 21 is between 16 and 25. So square root of 21 is somewhere between square root of 16, which is 4, and square root of 25, which is 5. So that's basically everything that we need for an ellipse. We have just vertices and the focal points. And now we're ready to go back and look at the shifted conic. And basically what we're going to do when we graph this is, remember, if I have an x plus 3, this is going to move the entire graph 3 units to the left. And if we have a y minus 7, I don't know why I picked such a big number for 7, but we're going to move this 7 units up. And so what this shifted conic is going to look like. So first of all, this is unshifted. And so what the shifted conic is going to look like is we're going to take basically the same graph, except we're just going to move everything here 3 units to the left and 7 units up. Okay, so that means that instead of going from -5 to 5, the values are going to go from 2 to 12. So let's look at 5, 10, 11, 12. And then the values, instead of going from -2 to 2, are going to go from -5 to -1. Okay, and so then our vertices are going to be at -3, and then 7 plus or minus 5. Okay, so basically what I did is I took this expression for the vertices and I changed the first term, I subtracted 3, and the second term we added 7. Okay, and so you get -3, 12, and -3, -3, 2. So those are going to be the vertices. Okay. The points here that were on the x-axis were at -2, 0 and 2, 0. So those will be -5, 7 and -1, 7. Okay, and so there's our conic. And then our focal points, I'm going to do the same trick. I'm going to take the x value of the unshifted and subtract 3. And then we're going to take 7 and add that to the y value. So you get 7 plus or minus square root of 21. Okay, so those are going to be the focal points of the shifted ellipse. So basically, that's really how we're going to deal with unshifted conics. So there's not too much more to talk about. It's just that you first figure out the information from the unshifted part, and then you can adjust all the terms accordingly, just according to how this was shifted. Okay, so that's what happens when we're actually given the formula here. Okay, so here we were given this formula. And so what I hinted at before was that maybe there's times when instead of being given this formula, you might have to actually derive this. And so what I mean by that is that if I were to take something like, and I'm just going to make up the numbers here, so this might not be very nice, but if I was just to take something like 2x squared plus 6x plus, say 5y squared plus 10y equals 4. If I were to take something like this, it's not clear anymore that this is even an ellipse, but what you would have to do is you would have to complete the square twice. And so what I'm going to do is I'm going to factor a 2 out of the x terms. So we'd have x squared plus 3x. And I'm going to factor a 5 out of the y terms. We'd have y squared plus 2y equals 4. And then there's kind of two ways that you can think about this, but I like to just complete the square under the parentheses, and then I'll deal with the other terms. I think that's easier. And so what I mean by that is I want to figure out what do we have to add to x squared plus 3x to make it a square. And so what you do is you take half of 3, which is 3 halves, and then you square it. You end up with 9/4. And of course, I can't just add 9/4 to one side of the equation. I have to add it to the other, or I have to also subtract it from the same side. And I like the subtracting method a little better. Likewise, for the y terms, we have y squared plus 2y plus 1 minus 1. And now what I'm going to do is I'm going to take our terms in front and multiply them with the terms that we subtracted, and then move those over. And so what's going to happen is we're going to end up with, let's see, so this is going to be 2 times the quantity x squared plus 3x plus 9/4 minus 9/2 plus 5 times y squared plus 2y plus 1 minus 5 equals 4. And then I can take the 9/2 and the 5, move them over, and we're going to end up with 2 times x squared plus 3x plus 9/4 plus 5 times y squared plus 2y plus 1. That's equal to 4 plus 5 plus 9/2. And so this is going to be 2 times x plus 3/2 squared plus 5 times y plus 1 squared equals, let's see, 9 plus 9/2 is 27/2. And then finally, remember the form that we like to have these in is that we like the one side to be equal to 1. So I'm going to divide both sides by 27/2, or multiply by 2 over 27. And so this is going to end up being, we're going to have x plus 3/2 squared over, this would be 27 over 2, but we have a 2 up top. So this is going to be 27 over 4 plus y plus 1 squared over 27 over 10 equals 1. Okay, and so again, ugly numbers, but that's how you go from this kind of general second degree polynomial to something that now clearly is an ellipse, because now this is like x squared over a squared plus y squared over b squared equals 1. Okay, so very clearly an ellipse now. Okay, and that's basically how you deal with shifted conics. So hyperbolas and parabolas are going to be the same. So just to quickly talk about that, if you were to have something like y equals 4x squared plus 3x plus 1, what you can do is you can write this as a square. And so you end up with y equals, so we'd factor out the 4, x squared plus 3/4 x plus 1/4. And then do the same trick as before. So you get y equals 4 times x squared plus 3/4 x plus, we want this to be 9/16. So we're going to add 9/16 and subtract 9/16, and we still have our plus a fourth from before. So 9/16 came from, 9/16 is wrong, by the way. It should be 9/4. Because I forgot to take half of it. So we take half of 3/4. So that is, I can't do algebra. What's the matter with me? So we get half of 3/4 is 3/8 squared. So that should be 9/64. And still plus our 1/4. Yeah, so still plus our 1/4. And so here we've added and subtracted this magic term that we need to make it a square. So this is going to be, so this tells us that y is 4 times x plus 3/4 x plus 9/64. And then if I, let's see, we have minus 4 times 9/64 plus 4 times 1/4. So 4/64 is 16. So this is, we're almost done. X plus 3/2 squared. Nope, 3/8. Minus, this is 9/16 plus 16/16. So that's plus 7/16. And then this is going to be very similar to the conic y equals 4x squared. And so that's going to be y equals x squared over 4p, where p is equal to 1/16. And so that tells you that your focus would be for the unshifted. Your focus would be 0, 1/16. Your directrix would be y equals negative 1/16. And then just think about what's going to happen here when we're talking about this quantity. So here we're shifting our x values to the left by 3/8 of a unit, and we're shifting up by 7/16 unit. So just to be clear about why this happens, here we're adding values to x. Here we're subtracting values from y, because if you were to move this to the other side of the equation, this would be y minus 7/16. So really you're going up 7/16 units. And so what happens is your focus for the shifted conic would be, so you're going to take the 0 value and subtract 3/8. You're going to take the 1/16 value and add 7/16. And so your focus would be negative 3/8, 1/2. Okay, and then your directrix would end up being y equals negative 1/6 plus 7/16. So you get y equals, so negative 1/16 plus 7/16, which is 6/16 or 3/8. Okay, so your directrix would be the line y equals 3/8. And then if you were to graph this, this would end up looking like, so we would have our directrix would be y equals 3/8. So something like that. Our focus would be negative 3/8, 1/2. And then the parabola would be something like here. And your vertex would be this point here. Okay, so that would be the point that's the very bottom point. So instead of being, so here your vertex would have been 0, 0. And so here we're taking this, and our vertex is going to be negative 3/8, 7/16. Okay, and so that's what that's going to look like And that's how you deal with these shifted conics. Okay, hyperbolas are totally similar. We can do a few in class, but this should at least give you the idea and basically all the tools that you need to solve these problems. Okay, and I think that that's actually, once we've done that, we've done everything from section 10.5. Okay, I will do some videos on 10.6, but I will do those later. So I'll do those probably next week. So this should at least give you a good, this is basically going to cover everything that we need to do in 10.5.